Welcome to the video on recrystallization. Recrystallization is a purification technique that's based on solubility. What happens is, if we have a compound that is not pure and we dissolve it in a hot solvent, we use the idea that compounds are more soluble in hotter solvents. We create this saturated solution of our compound. Then once we start to cool that solution, our product will crystallize first because it's in higher concentrations. And so as we decrease the temperature, our product will crystallize or fall out of solution as a solid, and then we can filter it, collect it, and we have a more pure compound at that point. This process can be repeated as many times as needed. The bottom line in this experiment is that we want to add as little as possible of our solvent so that everything just dissolves, and then we can cool it and see what crystallizes out. For this lab, we will complete the purification on pure phthalic acid, followed by a second recrystallization, which involves impure phthalic acid. We will take the melting points of both the pure starting material, the impure starting material, and both of our recrystallized product, and we will determine the percent recovery so that we can see how this recrystallization process both purifies and also affects the percent recovery. All right, let's go to the lab. Place about 1 gram of pure phthalic acid into a 25 or 50 ml Erlenmeyer flask. Record the weight in your notebook up to 3 decimal places. Place 10 milliliters of water in a graduated cylinder and add 8 mils of the water to the solid in the flask, along with a magnetic stir bar, and then begin to heat that mixture on a hot plate. As soon as the water begins to boil, continue to add drop-wise from the graduated cylinder more water until the solid just completely dissolves. If you've added 10 milliliters and your solid is not all dissolved, you can get more water and add it, but remember, add it cautiously and slowly. We want the solid to have just barely dissolved. Be sure to record the total volume of water that you added in this process. Once it is all dissolved, turn the hot plate off and allow the solution to cool to room temperature. Once you turn the hot plate off, you should leave the flask undisturbed. After a few minutes, you could carefully transfer the Erlenmeyer flask to the bench top to allow it to come to room temperature a little bit faster. When the flask is at room temperature, you can carefully place it in an ice bath to facilitate the crystallization. See the crystals forming here? After your sample sits on ice for about 10 minutes, get your Buchner funnel ready and insert a filter into the Buchner funnel. Pre-wet the filter with cold water and place your funnel in the side arm filter flask that's in the hood. And then you're going to carefully transfer all of the solid into the Buchner funnel. In this step, you can use a spatula to try to get more of the solid out, and ultimately you might use a cold water bottle to wash the solids off the side and get more out. Turn the vacuum on, and then you can wash your crystals with cold ice water while it's filtering. At this time, you're going to want to let the crystals dry with continuous vacuum for about 5 minutes. When you're done, transfer the crystals from the funnel to a pre-weighed watch glass and obtain both the final mass and the melting point. At this time, you will go back and repeat this recrystallization, but this time we are going to use an impure phthalic acid. Do exactly the same thing. Dissolve your sample in hot solvent, add hot water until all of your sample dissolves, and then once it all dissolves, you can bring it to room temperature and then put it on ice and get it to crystallize, and then we're going to filter it, we're going to weigh it, the same as we did in the first round. Recall, for the melting point, you're going to want to pack that capillary tube with your product, tapping it to try to get the solid all at the very bottom, packed nice and tight, just like this. If you can't get your sample to pack tightly at the bottom of the capillary tube, we have this device in the lab, which is just a long tube that you can use to drop your capillary tube from a higher distance to get packing a little tighter. Just a little trick. Once your sample is packed nicely in your capillary tube, place your sample in the melt temp and view through the viewfinder. Remember, when we are determining the melting point, we are actually not determining the melting point. We are determining the melting range. So you want to document when the solid first starts to melt, capture that temperature, and then also capture the temperature when it is completely melted. So you'll report a melting range for full credit in this experiment. You may recall that when you have a melting point of a pure substance, it is a much tighter range and it is much closer to the actual value. When you have an impure sample, you will have freezing point depression that broadens and lowers the melting point range. Just a little hint. And now, safety with Jane. Subbing in for Jane is me. The safety precautions for the recrystallization lab include: make sure you complete the recrystallization in the hood. Be sure to wear the required personal protective equipment at all times, including closed-toed shoes, appropriate leg coverage, lab coat, and of course, goggles. This lab involves heating of solvents and requires caution when handling those hot solvents. Do not breathe in any of the hot solvents, and remember, the heating mantle on the melt-temp apparatus will get quite hot, so be careful, and please don't forget to turn the melt-temp apparatus off when you are finished. Okay, as Jane would say, easy peasy. A big shout out to Tara and Katie for filming this experiment. There you have it, recrystallization laboratory experiment at Nazareth College. Good luck.